Hello, this is the luckiest maths teacher in the world. Today we're looking at scale drawings, both reading them and constructing them. So firstly, we're going to look at situations where you're given a drawing of an object and you have to measure it to find out its length in real life. So I've given you a drawing of bacterium, so bacteria is the plural of this, so this is just one of them, and I've given you a scale, and I'm going to show you how we figure out its length in real life. So we need to actually measure this using our ruler, and you'll be doing questions like this in class. The problem is, of course, though, the actual length of this will depend on the size of the screen that you're watching it, so I'm just going to give you the dimensions. So when I measure it on my iPad screen, I go from the leftmost point to the rightmost point, it came up as 7 centimeters. So that's its length on the drawing. That's the drawing length. So we're going to use the scale to find out how big it would be in real life. Now this scale probably looks a bit weird to you because the bigger number is first, which is not normally how it goes. But remember, I told you last lesson that this can happen. It means an enlargement. It means that this drawing of the bacterium is much, much larger than the original. And as I hope you know, bacteria are too small for you to actually see with the naked eye. So that's why we would need to do an enlargement drawing of it. So what this scale, 250,000 to 1, means, remember the first number is always the drawing and the second number is always real life. What that means is the length of this object in this drawing here is 250,000 times larger than what it is in real life. So if I want to find out what its length is in real life, I have to divide. So I'm just going to take 7 centimeters and I'm going to divide by 250,000 because that's the scale. So if I do that, I get 0.00040 zeros and then 28. Now because it was 7 centimeters in my drawing, this is in centimeters. So we can make this an easier to understand unit. So if I times by 10, I get 0.00028 millimeters, and I can times that by 1,000. So I move the decimal point 1, 2, 3 spots. I get 0.28 micrometers, or if you know what it means, that's 280 nanometers. Okay, so that's an example. We divided because this was an enlargement, because this is larger than the original. We'd end up multiplying if the scale drawing was smaller than the real life object. And we'll see that in the next example, but the next example has a bit more to it. So please pause and copy this down if you need. Okay, so this is the kind of question that we might do. We're given a diagram, a scale drawing, and what you will normally have to do is measure dimensions and use that to solve problems involving lengths, area, cost of painting, tiling, or whatever. But in this case, I've given you all the dimensions. I've actually measured them out because, as I said earlier, it will depend on what screen you're watching this on. So we're going to go ahead and use this scale drawing. So what we're going to do, we have a scale drawing of a shed, and we're going to figure out how much it will cost to paint. So we're going to have to figure out the total area of all the walls. We're told not to include the window, but we have to include the door. We need to give it 2 coats. 1 litre of paint covers 7 square metres, and each litre of paint costs $12. So what we first have to do is figure out the area to be painted. So what we're given here is we're given a front view of the shed and a side view of the shed. So obviously we're assuming here that the front and the back have the same area, although the back doesn't have a window, and also the 2 sides have the same area. So let's find first the area of the front elevation. So I've told you that this drawing is 3.5 centimeters by 5.4 centimeters. So we're going to use this scale here to figure out how much the area is in real life. Now you can't just times 3.5 by 5.4 and then times by 90. What you have to do at this stage is first convert them into their real life dimensions. So 3.5 centimeters. So that corresponds, so to find out how much that is in real life, I'm just going to multiply it by 90. Now the answer I get on my calculator is 315. This is 315 centimeters or 3.15 meters. So I'm going to do the same with 5.4. I'm going to times it by 90. I get 486 on my calculator. But that is 486 centimeters, so 4.86 meters. So I'm going to do the same for the side plan of it. I don't want to include the roof because I'm only including the walls. So I know that it is 3.15 meters high, the same as the front. Now 8.2 centimeters, again I'm going to times that by 90 on my calculator. I get 738, which is 7.38 meters. So the area of this front elevation, the area of the front wall, is 3.15 meters by 4.86 meters. It's just the area of a rectangle. So that's 15.309. And that's obviously meters squared. And then I'm going to do the same for the side walls. I just go 3.15 times 7.38 meters, and I get 23.247 meters squared. I'm not going to round either of these at the moment because there's only 3 decimal places to write, and if I round now, my calculations down the track will be inaccurate. So the total area that I need to paint 2 lots of the front wall, and I need enough paint for 2 lots of the side wall. So that's, of course, just 2 lots of 23.247 meters squared. But I'm forgetting something. I need to subtract the dimensions of the window. So I need to figure out the area of the window in exactly the same way. Now, again, you'll need to measure this in your textbook when you're doing questions, but I'm just going to give you the dimensions now. So this window is 1.5 centimeters by 1 centimeter. So the area of this window, I need to again convert them into meters. Everything else is in meters. So 1 centimeter, 1 times 90 is 90 centimeters or 0.9 meters. 1.5 times 90 is 135 centimeters or 1.35 meters. So the area of this window is just 0.9 times 1.35, which is 1.125 meters squared. So the total area that needs to be painted is the 2 lots of the front, which I have here, 2 lots of the side, but I need to minus the area of the window. So I need 75.987 square meters painted. So I'm told that 1 litre of paint covers 7 square meters. So I'm just going to divide that by 7, and I need 10.86 litres. So I've rounded that to 2 decimal places. I need that to cover the 75.987 meters squared, but because I'm doing 2 quotes, I then need to double that, and that means I need 21.72 litres overall. So if they come in 1 litre cans, I need to round this up. I need to buy 22 litres at $12 a litre. I just times 22 by 12 and I get $264. That's how much it will cost. So we've used a scale drawing plan to figure out the cost of painting it. Sorry that was a long example. So I just have to do 2 quick examples involving constructing scale drawings now. So please pause and copy this down if you need. Okay, so in the last example, you were given a scale drawing and you're asked to solve problems with it. Now we're looking at constructing scale drawings. This time you don't have the scale drawing, you have to figure out how you would construct it. So we're talking about a rectangular floor plan that's 12 meters by 6 meters, and I want to draw it on A4 paper, also rectangular, 297 millimeters by 210 millimeters. I want to allow margins of 2 centimeters in each direction on the paper, and I've got to figure out the scale that I am going to use. Now, the instructions for how to determine the scale for a scale drawing, they are listed on page 309 of your textbook and also the slides that accompany this. So I'm going to follow them, and there's 5 steps. So the first step says change the measurements of the real object to the same units being used on the drawing paper. So the drawing paper that I'm told about, the A4 paper, is in millimeters, as you see here. So what I have to do is I have to change the measurements of the actual object, in this case the floor. I have to change them into millimeters. So hopefully you realize by now that there are 1,000 millimeters in a meter. So 12 meters is 12,000 millimeters, 6 meters is 6,000 millimeters. So that's step 1 done. The second step says determine the size of the space available allowing for margins. So of course 2 centimeter margin is 20 millimeters. So what I am going to do is I'm going to leave a 20 millimeter margin in all directions. So really, you're going to have 20 millimeters less at the top, less at the bottom, less at the left, and less at the right. So the actual space you have for drawing is only going to be 257 millimeters by 170 millimeters. So I took off 2 lots of 20 millimeters. So if the paper, of course, is 297 this way, I lose 20 millimeters at the top and 20 at the bottom. That's why I took away 2 lots of 20 millimeters. And the same for going across. I'm going to lose 20 millimeters here, 20 millimeters there, so I subtracted 2 lots of 20 millimeters. Okay, so the third step, divide the size of the real object by the size of the space for drawing in both directions to obtain a scale factor for each direction. So what does that actually mean? What it means is I take my longer dimension for the real life object, and I am going to divide that by the longer dimension of the paper. So 12,000 millimeters divide 257 millimeters. And the answer I get is 46.7. I've rounded it. So I'm going to do the same for the other dimension. I'm going to line up the shorter dimension in real life with the shorter dimension on the paper. So I just go 6,000 divided by 170. Again, I'm going to round it. It's 35.29. What this means is to fit this drawing exactly within these dimensions, I need a scale factor of 46.7 for the longer side and a scale factor of 35.29 for the shorter side. If it's a true scale drawing, I can't have different scale factors for the length and the width. So what I do is I choose the larger one of these. If I choose the smaller, then this one here won't fit. The 12 meter rectangular floor plan, that dimension won't quite fit within paper of this dimension. So I always choose the bigger scale, so the scale 46.7. But that would make things difficult, because if I have a scale of 1 to 46.7, that means every time, I have a meter in real life, I have to divide it by 46.7 to figure out how long it's going to be on the actual drawing. So I don't want a number by 46.7, because that's not an easy number to divide by. That would be really hard to make my drawing exactly accurate. So what I do is I round up. I pick a number that's easier to work with. So 46.7 is close to 50. So I'm going to pick a scale of 50. That's much easier to work with. So if the scale factor was something like 93, I could round it up to 100. You want to pick numbers that are easy to work with. So numbers like, 4, 5, 10, 50, 25, 100, 200, 300, they're much easier to work with because whatever the number that you choose here, you're going to have to divide measurements by that number, and we want a number that's easier to divide by. So what I'm saying is, so for example, let's say that there was something I wanted to represent that was 1 meter. Let's say a room had a length of 1 meter. It's a lot easier to divide 1 meter by 50 than it is by 46.7. So 1 meter, if I divide that by 50, well, 1 meter is of course 1,000 millimeters, and if I divide that by 50, that's 20 millimeters on my drawing. But if I have to divide 1,000 millimeters by 46.7, I get like 21.413. So that means that that room would have to be 21.413 millimeters on my drawing. So it's much easier to pick numbers like this. So the scale is going to be, the scale I'm going to use is 1 to 50. And remember, the second number is going to be larger here because it's a reduction. The scale drawing is smaller than the object, in this case the room. All right, I have just one more quick example to go. Okay, so this time we're given the dimensions of a rectangular floor plan, but instead of having to find the scale, as we did in the last example, we're given the scale and we have to find out the dimensions of this room on the drawing. So this is actually really easy. So if the rectangular floor is 4 meters by 3 meters and the scale is 1 to 40, all you need to do is divide by the scale factor. Remember, this scale of 1 to 40 means that the actual object, the floor, is 40 times larger than the drawing. So if I want to figure out what this is on the drawing, all I need to do is divide. So first thing though, I'm going to take 4 meters and I'm going to change it into millimeters. So floor plans, architects, they always use millimeters so they don't have to round. So then 3 meters is 3,000 millimeters. And so to find the actual dimensions, I just divide each of these by 40. So 4,000 divided by 40 equals 100, in this case millimeters. So the length of the rectangular floor, which was 4 meters, it's going to be represented in 100 millimeters or 10 centimeters on the drawing. I then do the same thing. 3,000 divided by 40, and I get 75 millimeters. So the width of this room, which is 3 meters in real life, will be 75 millimeters on the drawing. Hope you've enjoyed the video. Sorry it was another long one. This has been the luckiest maths teacher in the world. Have a great day.